Welcome to Get UV'd with Matt, otherwise known as Disco Party. We're going to be looking at how UV affects QC and how that phosphorescence can tell us the history of the coffee. So we see in natural light, it's a part of the electromagnetic spectrum, and we see the reflections of what light isn't absorbed. UV works in a similar way. It's a shorter wavelength than we can see naturally. We can see it with polarizing glasses and a UVA torch operating in around 390 nanometers. What we do is we shine this on the coffee, and compounds within the coffee will phosphoresce. We don't know exactly what it's linked to, but the common thought is that it's linked to lipids within the coffee and some sort of breakdown within the lipids that causes phosphorescent compounds. Rule number one, this is not a rejection method. We cannot reject coffee based on this. It does not show us Rio, it does not show us phenols, it does not show us stinkers, it does not show us black beans. What it does show us is how the coffee's been processed from primary processing through to drying and dry milling. So we have a range of samples on the table, some washed, some natural, and a couple of surprises later. This one, as you can see, is super clean. This is the reference profile. It's been well processed, it's been well dried. There is virtually no glow in there. A few tiny little spots, but nothing major. Okay. Moving on. This one has some significant glowing beans. These bright glowing beans that I'm going to hold up now. This has happened in the fermentation phase. The two things that affect these phosphorescent compounds are going to be moisture and heat. So at some point, something about these beans has taken on too much moisture or too much heat, and it's changed the nature of them. What we do know is these will be lighter, less dense, they'll be less moist, and they'll be prone to age faster. If we roast a sample of separated out clean beans and the beans that are glowing, the clean beans will be brighter, more vibrant acidity. These will be most likely flat, dull, and a little bit papery, like faded coffee. Cool. So this is fermentation damage. Moving along, this is a clean coffee as well, so like our reference sample. But what we have in here is we have a few little dots. So here's a good one, just on the end there. That's most likely pulper damage. You can also see it when it's going to be insect damage bites or perhaps a tiny bit of mold. But you get these little glowing dots when the pulper plates are too close together, and that allows moisture and heat inside that spot on the bean, and it shows us that there's something wrong in the processing. But after that, it's clean and it's been dried well. Okay, perfect. Next sample. You see how it's a very uniform, dull glow? Yeah. There are a couple of thoughts about what's happening here. Nothing here is glowing really bright like a jewel, like these ones in here. Yeah. What's happening here, we think, is either it's got too hot during drying, and this does happen during drying. Say if temperature get consistently above 45 degrees for a long time, what we think happens is the moisture will evaporate off the bean, get trapped inside the parchment, and form a kind of pressure cooker. And that will oxidate the lipids really very fast and will start the glowing process. The other thing that can happen, surprise reveal, is that we can have issues in the milling process. If the coffee is moist and it goes through the mills can be very, very hot. And we have, example here, we get whiting of the beans. And that, in moist coffee, extra heat from the milling process is going to cause that lipid degradation, and we're going to get the glowing beans. This sample, milled 3 times. This sample, milled once. Oh, wow. See how it's significantly different? Yeah. Much more glowing beans, much less glowing beans. Naturals. These are both anoxic naturals, so they're happening in our water pillar process, so we do have the heat sink there. Same fermentation time. The key difference here is different varieties. So this is Castillo and Valle de Colombia. As you can see, we have some very, very clean coffees. We have some of the bright jewels, but the overall drying is very good. So we don't have any of that edge glow. This has also been conglomerated over a long time. So this is like a full day or 2 days of cherry collection. Okay. This, same process, but Gesha. Okay. So 2 possible things are happening here. Either the Gesha variety takes on heat and temperature in a different way, causing a little more glow as we go along, or it's because it's a single conglomerate collection. And that's why we have a more consistent glow across. Yeah. Okay. The key thing here is this will age faster, because more glowing beans usually a signature of a faster aging. It does not signify anything to do with quality, because this is a 90+ coffee, this is a high 80s coffee, which is why we can't use it as a rejection method. Last sample we have is decaf, and that's been post-processed by resaturation and steam saturation as we've seen in Descafé Cold, and that changes the nature of the lipids within the bean. So we end up with a very different glow altogether, and everything is uniformly exactly the same color, which nicely backs into our theory that it is to do with lipids. What we need to eradicate here is maybe it's the carnauba wax, but we'll look at that in the long run. Cool?
Cool.
Okay, so the key thing here is we need to avoid excess moisture, excess temperature, and if we do that, we can prolong the shelf life of our coffees as long as they are also dense. We want coffees to look like the reference sample and not full glowing like this.
Like this one.
Cool?
Cool.